but this was actually kind of part of the reason April ended up being so active. And I'm going to talk a lot about this outbreak, and then at the end, if we have time, we're going to talk about a little about social media and weather. Actually, a part of a presentation I gave 3 years ago at the National Weather Association annual conference about how social media was going to take over weather. Who would have thought it really would, as much as it had. But I did want to talk a little bit about myself, because after Bill talked this morning, I kind of felt bad that I'm just meeting a lot of you for the first time. So I wanted to kind of tell everybody who I am. Originally from Ohio. I got my degree from the Ohio State University in atmospheric science. Why didn't the computer go? Yeah. See, it's in there. Currently the chief meteorologist at WCNC in Charlotte. This is the key thing I wanted to say, because I do this all the time. It's my laser pointer down here. There we go. I never wanted to be on TV. It's kind of funny, because when I grew up in Ohio, my first weather memory was when I was 6 years old. It was the blizzard of '78. And I remember our house being snowed in, and my dad having to climb out the first-story window to dig out our front door. And I just remember looking out the window and wanting to go out there so bad. My mom finally put me in my Ohio-issued snowmobile suit, and I went outside and just staring up at these 6-foot drifts, and I'm just in awe, and knowing that I wanted to figure out how, what, and why that happened. But ever since then, I can remember never wanting to be on TV, because all the guys I watch on TV were horrible. They never got the forecast right. So I don't want to be one of those lame TV weather guys. I wanted to be a meteorologist. I wanted to chase tornadoes and fly into storms. So I kind of came into TV from the back door. So it kind of gives me a unique perspective on the business as well as meteorology. So I'll talk more about that as we go. If you do follow me on Twitter, Facebook, my blog, the forums, I'm WX Brad. Most people know me online as that. Where have I worked? Well, obviously I was born in Chicago. We moved to Ohio, Copley, Ohio, when I was 6 months old. I went to Ohio State. My first job in TV was in Dayton, Ohio. I was in the synoptic lab at Ohio State University one day, and this guy comes in. He's a meteorologist over in Dayton, and he's doing some research over at the synoptic lab at Ohio State. And he's like, "Hey, is anyone graduating soon?" I said, "I am." And he said, "Would you want a job?" And at this time, the National Weather Service had a hiring freeze. So I was really worried about getting a job when I graduated. And he's like, "Well, would you think about doing a TV gig?" And I was like, "I don't know about this TV thing." So he's like, "Why don't you do an internship at a local station, send me a tape and we'll talk." So I did an internship and was blown away by the TV station having their own C-band radar and millions of dollars worth of computer equipment, that I really quickly became a weather producer in Columbus, Ohio for the CBS affiliate. But this guy over in Dayton kept calling me, wanting to know if I was interested. And so finally I sent him a tape. And next thing I knew, I was getting up at 2:30 in the morning to go to work to do the morning show at the NBC station. I didn't know anything about TV, except for what I was learning in my internship. So I had to learn the TV part of the business on the job, whereas I was much more of a weather geek from the get-go, and the TV stuff had to come kind of secondary. Hardest part about working on TV wasn't talking about the weather in front of the camera. It was trying to do it in 30 seconds at a time, and do it in 2 minutes at a time. Time constraints, I'm horrible with them. So it was always easy for me to talk about weather in front of people. It was always hard for me to do it in the time constraints that TV did. So I'm there 6 months. I get a job offer to go up to Traverse City, Michigan. Beautiful country up there. Beautiful. Snows 6 months out of the year. Lake effect from every direction but south. And everyone has snowmobiles. You drive your car across the lake on the ice in the winter, and then you boat on it in the summer. It's pretty much what you do. Loved living there. And then out of the blue, at the AMS conference one year, same story. Someone comes up to me, "Hey, we got a job opening in New Orleans, Louisiana. Would you be interested in that?" I don't know about that. I don't really want to live in New Orleans. You know, I'm from up north. Why would I want to go to New Orleans? So I take the guy's card, have a good time at AMS, go back up to Traverse City. We have a station meeting. General manager goes, "Guess what? I'm selling the station." And I go, "Well, guess what? I'm going to pull that card out and call that guy up." So I gave him a call, and they flew me down there and gave me a nice pay raise, but I had to do weekends, and it was culture shock. I'm not going to lie. Going to New Orleans, Louisiana, from Traverse City, Michigan was amazing. And I always joke that the thing about living in New Orleans, if you're a meteorologist, there's only 2 seasons, summer and hurricane season. That's really all there is to it. But I did enjoy my time down there I got to fly into about 7 hurricanes, because when you're in New Orleans, you only have a short drive over to Keesler Air Force Base to hop on the Hurricane Hunters and fly into any storm you want, as long as you call the press officer over there. And so I got to fly into Floyd when it was off the coast of Florida. I think like Bill, I must have thrown up like 3 times. Because the thing about flying in C-130s into hurricanes is there's no windows. And you're in the back on these metal bars and nylon straps, and you're dropping 5,000 to 6,000 feet in a second, going back, and you can't see anything, you can't see the horizon. So if you have any inkling of motion sickness, you're going to get it. And the only way you can go to the bathroom in there is a porta-john strapped in the cargo hold. And so it's not really glamorous, and it's a 12-hour mission flying in there, but when I got to the eye, it was the most spiritual thing I've ever experienced besides chasing tornadoes. Just this cathedral type thing where you're just staring down at the ocean with white caps up to blue skies with stadium effect in the eye wall. It was unbelievable. So one of the cool things about living down there was being able to fly into hurricanes, and I flew into about 7 of them, mostly tropical storm, but Floyd was the big one when I first got there. I stayed there 4 years. My company, Belo, is based out of Dallas, Texas. We own this station up in Charlotte, North Carolina, and I couldn't wait to get out of New Orleans. So when the job came open in Charlotte, I applied for it and got it. And when I got up there, I loved the Carolinas weather. 4-season climate, 3 months of everything. Ice storm capital of America. First week on the job, we had a huge ice storm. If you love cold air damming, or if you like not to be able to get a forecast right, try forecasting in the winter down here sometimes. So I'm there about a year, and something happened down in New Orleans that they flew me back for. This thing right here. That was Hurricane Katrina. And this was about the time I was flying into New Orleans. I flew into New Orleans to help out my former station because their morning Met had left to go to Miami, Florida. David Bernard, who's now at CBS affiliate down there, and it was me and the chief meteorologist. We were the only Mets at the station. And so this was my hotel room. This is the Hyatt Regency Superdome. After I rode the storm out, went up to get stuff. I had a whole bunch of nice stuff right here that is out here somewhere, and probably halfway to Mexico. That was the view out my window, the broken glass and the roof of the Superdome. And it wasn't fun. We rode the whole storm out in a room about this size on the 3rd floor with dogs, cats, sick people, no air conditioning, no running water. I was only there a day, and I left with the station because we had escort to go back to the station. And I come to find out a lot of people in that room ended up staying there for like a week in those type of conditions. That was the hotel. My room was like up in here, 15th floor. We actually wrote it out down here though, so they didn't let us stay up in the room. That was the side that faced the Superdome and the rest of the city. What happens is all these roofs have those stone asphalt roofs, and all those stones get blown off. They get thrown in the side of the windows and pretty much break every window. That was me going back the next day. This is at the station. We had an escort of military people to go back and grab. I had to grab the weather computer actually and bring it up to Baton Rouge. I ended up staying about 3 weeks, based out of LSU and eventually Louisiana Public Broadcasting, where we stayed on the air the whole time. This station never went off the air. Our transmitter was built to withstand a Category 3. So we were the few station that was able to stay on the air the whole time. And then this is what it looked like north of the lake where I used to live. You went from flood damage in the city to this everywhere you look. There's giant tall pine trees knocked down. So this was probably ended up being my biggest defining weather moment, having to work a storm like this. And the hardest part for me was working. I chased a lot of storms, get geeked up about a lot of weather, but this is the first time I worked somewhere where all my coworkers' houses were either destroyed or their families were displaced. So it was really hard to kind of work a situation like that where everybody you worked with was personally affected. So it was a defining moment in my career, but it was also one of those things that was really hard. I remember one morning I was working on the air, and NOAA was flying those aerial missions where they were taking pictures of the neighborhoods using the Cessnas. And I was calling them up on our weather computer, and we were panning and zooming around, and I remember the morning anchor saying, "Hey, can you pan over? My house is right over to the right of there." And I didn't want to. When I did, panned over, and you could see her house was completely underwater. And then she kind of lost it on the air. So that was kind of a difficult time to work with. And then I ended up going back like a week later to do Rita, which was a whole nother month and a half. So needless to say, after the hurricane season of 2005, I was worn out with hurricanes. They had sent NBC and the Weather Channel, went down with them to help them out in Fort Myers for Wilma that same year, and it was in October. It just seemed like it never ended. So that's the first time in my career I probably was, like, say, getting tired of covering severe weather for a while. Until this year. In the spring I got a little tired. I never thought I would hate severe weather. But this is kind of the rundown of my talk here. Talk about tornado climatology of North Carolina tornadoes, brief history of a previous event that was the record, some of the synoptic and mesoscale setup. I'm going to talk not as much about that. I'm going to talk more about some things that I kind of detected that day. Some of the stuff is theoretical that I think contributed to this, and ends up, a lot of this stuff could have been repeated in Alabama, could have been repeated in a couple spots this spring. The death toll, and then if I have time, I'm going to go into social media and the impact on weather. First thing you got to know about North Carolina tornado climatology. Now this is the numbers from 1953 to 2004, how many tornadoes you average per state. North Carolina averages 19 per year. That has not changed even since 2004. That's roughly about the average we get, which doesn't seem like much, but you look at the rest of the country and really, on an average year, the numbers really aren't all that impressive when you look at on the average. But here's something that I don't know if a lot of people know about. This research is becoming more and more prevalent. Looking at long track EF3 and EF4 and 5 tornadoes now, looking where they occur. And now you're starting to see different quote-unquote tornado alleys. And Michael Frey's up at the University of Akron. He's detected, based on the number of tornadoes, you start to see these other kind of alleys. Dixie Alley, which obviously is becoming really big in the last couple of years, but there's this little Carolina alley we're going to talk about here in the eastern part of North Carolina that tends to get a lot of tornadoes. And when you look at the previous tornado record for North Carolina in 1984, you notice that there are a lot of tornadoes in the eastern part of the state. Not very many in the mountains. And all my mountain viewers, I actually cover these 3 mountain counties. My viewing area stretches from here to here and halfway to Columbia, South Carolina, so I have a huge viewing area. But everyone in the mountains thinks tornadoes never happen up there. Well, they don't, but as we saw this year in April, several deadly tornadoes occurred in eastern Tennessee and even western Virginia up in the mountains. When you look at observed tornadoes by county, there is some population bias in these numbers because that's Charlottes County, that's Winston-Salem, Greensboro, and that's Raleigh. So you can see there's definitely some bias, and then this is mostly tropical in nature. Yeah.
I was just going to ask you that.
Yeah, this eastern part, these are inflated because of tropical cyclones. So you'll see those numbers wet. But when you look at death toll and injuries, you notice a big peak here. Now, partly this is because there's more tornadoes out here, more long-track tornadoes, but there's a lot of manufactured housing out here as well. The eastern part of North Carolina, if you've ever been out here, it's all pig farms and manufactured homes, and a lot of military, obviously. So when you look at fatalities, you notice the number of fatalities in the eastern part of the state peaks in that same area. So there's something going on in eastern North Carolina when it comes to tornadoes. So this is the previous tornado record in North Carolina. This is strictly by number of tornadoes. And this was the March 28, 1984 outbreak. There was 42 deaths, and there was 15 total fatalities in South Carolina, which is also important because this had a couple of these long track EF4s here started in South Carolina. And then the number of injuries. So you can see though that where these tracks are in that same spot, Carolina Alley. Now when you compare that to the April 16th outbreak this year, you see the same kind of setup here. Eastern part of the state getting hit again. Here's your long track tornadoes in here. And you can see the only different thing about this was that we did not have anything above EF3 in this outbreak. So there were a lot of long track tornadoes, but none of them rated higher than EF3. So if you compare the two side by side, this is the new record, 30 tornadoes. This was the previous record, which was 25 total tornadoes. And as you'll see, 42 people died in this outbreak, even though there was less tornadoes than this outbreak, and we'll talk a little bit why I think that is the case. This is the 84 synoptic setup. You see the big low, here's your jet, your low-level jet coming in here. You'll probably notice a few things similar about the outbreak this year. That's in the upper air. Here's the surface chart. There's your low, there's your stall front. Now remember, this is late March too, so this is kind of odd to see something this strong in March in the Carolinas. Air is not particularly warm. If you look carefully, this is 75 over 64, there's a 60 over 53, oh, no, that's 80 over 63, excuse me, 77 over 69. So there's really juicy air down here that's being invected up into parts of eastern North Carolina. And this is an old chart. I actually think this is more of a meso low here. The surface low might be up in here with an inverted trough there. It's hard to tell on this chart, but when you look at the satellite image this is from 84, mind you, you can see these huge clusters exploding in the eastern part of the state, and then the upper lows back in here. So this was the 84 setup, and you look at the 2011 setup, this is a great map because it shows this 3-day outbreak. And I'm focusing on this outbreak here, but you got to remember this was part of a 3-day outbreak. And this was a huge outbreak before the mega outbreak later in the month that affected the Deep South. But we had tornadoes here in Oklahoma, huge outbreak of tornadoes south of where most of the ones were on the 27th, and then the Carolina outbreak. And you see the one thing that's developing as the day goes on, this triple point here, there's a meso low in here as well, which probably played a pretty large role in these tracks. And I actually, after seeing that on Friday night, I spent the whole night at the station thinking we were going to get clobbered, and ended up we barely got grazed. So here's this 14th of storm cranking up there. This thing here, I don't know if you remember that. That's not a storm. That's actually that big grass fire west of Dallas, and that air was getting ejected into the dry line right there. So that was kind of an interesting satellite image. But this is how this thing unfolded. It just plowed across the southeast. So here's kind of the overview of the whole system, the 14th through the 16th. This is the whole 3 days. You see 52 hours, maximum tornado again, EF3, 162 tornadoes. Damages, that number still up in the air. 43 over that 3 days, but 25 of those occurred in North Carolina. And we'll talk about that. You can see the numbers down here. Notice 14 EF3s, but no EF4, EF5s, which is a little different.
I thought Tullahoma was EF4.
Well, I think they did upgrade that after the fact. I think you're right.
Okay.
And we'll get to the multi-vortex tornado. I think did get upgraded. I thought that too, because this is the one memorable tornado that I'm talking about from Oklahoma. This was the first day of the outbreak, and a lot of people remember this tornado. It's got a lot of play on the national press because of the multi-vortices. And I do think that was upgraded to EF4.
Yeah, I think it was.
And then there was this one in Clinton, Mississippi. I remember this picture. I showed it on the air and I said, if I ever see any students staring out at this tornado like this, then I haven't done my job. This is a horrible picture in my opinion. But it was a great learning process, or learning picture for a lot of students, because this is the last thing you want kids doing, staring out glass plate windows of a tornado going by in Clinton, Mississippi. So that was the 15th. And then it was our turn. Here's the storm reports. We had a lot of flooding, wind, hail damage, but here's all your tornado reports in the eastern part of the state. And again, just to recap, that's where our tornadoes were in the eastern part of the state. So here's the elements that came together for us. This is a 250 millibar chart. You can see our inverted trough there. And that's kind of key too. This thing, you got this negative tilt to it as well. This is 500 millibars. And then the surface. And look at there, we have our little meso low right there. And there's our surface low back there with an inverted trough in the mid and upper levels. All of those led to this. This is the significant tornado parameter for that day. It was off the charts. I'd never seen it so high in the morning. We started getting the first warnings probably about 10 or 11 in my viewing area. We had a warning up here. We had actually a funnel cloud reported in Rowan County, and another one was reported down here. And if you remember, that was the first warning. This is what it looked like in the mid-morning. This line, broken line, this is the same line that produced the tornadoes down in Alabama. And at this point, I'm very worried because of what I've seen the night before. But so far, we haven't had time to really heat up yet. But even at the station, I was looking at my tower cam, and I could see the low-level cloud field, which, first of all, when we talk about this, the LCL was so low. The low-level clouds were coming in from the southeast. You could see mid-level clouds coming in from the southwest, and even high-level clouds coming in from the west. So you knew you had this varying wind with height. And this is about the time, SBC had put out that PDS tornado watch for a huge area. And we were getting these little cells out ahead of it that were starting to show signs of rotation as well. And you may remember then the high risk was issued for eastern North Carolina, which is a rarity. I've only seen a high risk issued for us like 3 times since I've been there. And this came out quick. In the morning, it was a moderate risk, and then boom, about 11 o'clock, we go to a high risk, and almost immediately a PDS tornado watch is issued. And then all hell broke loose. This line just absolutely exploded. And as I go through these, you'll see a couple things. This is GR Earth, if you're wondering. And when you see in GR Earth, you see this black line. These are confirmed tornadoes on the ground when you see that polygon showing up on GR Earth, which is a cool feature because when you're staring at the map and you see a regular tornado warning, but you see that, you know there's confirmation. So every one of these is spinning and moving into the eastern part of the state. And you can see as it progresses, everything. I mean, we're going from Charleston, South Carolina, up into Virginia. And I should mention, even though I'm focusing on North Carolina, there were a lot of tornadoes up in Virginia and a whole bunch down here in South Carolina as well. And even as it goes towards the coast, and you can see, I mean, I'm back here in the sun at this point, looking east, thinking it's amazing looking at the video and picture. We had chasers out here from our station following these storms as they're going up towards Raleigh. Almost impossible to keep up with some of these. And then I'm staring at the radar and I'm seeing stuff like this. And it's just unbelievable signatures coming out. Now this is Holly Springs. Sanford, where the Lowe's store was obliterated, is down here, and here's Raleigh. So now we're starting to get worried because this thing is tracking right towards Raleigh. Now typically you love to have spotter reports in this situation, but in this case, I know there's a tornado on the ground. I have a debris ball. And as I'm going to show you some dual pole products that confirm debris in the air. So you're getting velocity couplets that is showing massive rotation right over Holly Springs, which was heavily damaged. This is GR Analyst, and a couple cool features show up right off the way. This huge bounded weak echo region underneath, and if you look back in here, this is the descending reflectivity right in here. I'll put a little air on, you'll see it. So you can see that coming out of the back of the storm going down, and this is likely in here is debris. These high reflectivities, probably 65 to 70 dBz reflectivity showing up where the debris is getting pulled up. And here's a better view. This is the descending reflectivity coming down from that cell. And then look at, I mean, I can imagine being a chaser staring at this big bolt right there, that big bounded weak echo region with the descending reflectivity coming down the backside with the rear flank downdraft, the inflow coming in, and then all that debris spinning around right there. And this is the normalized rotation, great product. So you can see the tilt of the rotation and how deep it was. Very, very deep rotation. Yeah.
Given how fast they were moving, is that, when you say normalized, is it normalized for the storm movement? Because I'm wondering how much of that tilt was due to the fact that the radar is not sampling each vertical layer at the same time.
It could be part of that, but they were moving fast enough. I think the tilt may be over-exaggerated in this image, but I still think we're probably in an angle somewhere in there. But I think you're right. It's not able to sample all of those levels as well. Yep.
If you set the storm motion vector in the GeoTree Analyst, they'll actually try to adjust the 3 bodies for that.
Okay.
But that probably is some from storm motion.
Yeah, I think probably most of this is storm motion, but it would be subtle. But yeah, because of the speed, you're definitely going to lose some of it there. These are some of the dual pole images coming from the Raleigh TV station WRAL. We have a good relationship with them, and I'm pretty good friends with all their meteorologists. They're very lucky. They have a dual pole Doppler radar that's 1 million watts in Fayetteville, North Carolina. And the reason it's 1 million watts, people are like, it's a big number. You got to remember, dual pole, 500,000 of that's going in one beam, and the other 500 is going in the vertical. So to use your 2 dual pole, you got to split that up. So the more power you have overall, the better off you are. And this is looking at the CC. You're looking for basically where you're getting low returns because of the shape of debris, and you're looking for debris signatures. Oh, you lost an image there. Oh, they're all going behind there. All right, let's try this again. All right. So here's the image. This is the reflectivity from the same radar. You see the debris ball. And when you're looking at the CC on these, you're starting to look for areas where you have very weak returns on the dual pole data. And if you start to see this weakened area, and shows up very well right there. You start to get a hole. And this is where on the dual pole data, you're highly, highly confident you have a damaging tornado on the ground. Not only do you know there's a tornado on the ground, you know it's causing damage because this is picking up debris. And sometimes you'll see this on reflectivity data where you get a hole. This is dual pole data, so you're actually looking for weak returns there. But sometimes because of centrifugal forcing, you will sometimes get donuts showing up on the reflectivity. And sometimes if you look at some of the GR2 data, like from Greensburg, you'll start to see little holes. We call them vortex holes sometimes because all that debris is getting spun out from the middle and it's actually showing up as kind of an eye. So there's another view of it, and this is really close to the radar, which is in Fayetteville. And you can see the high return. You got that little ball right on the end of the fish hook there. And then there's the last image. Here's some more images as it approaches Raleigh. One of the interesting things about when it approached Raleigh, it was starting to occlude a little bit. The vortex was actually wrapping all the way around, and I'm going to show you some videos, you will see this kind of demonstrated in the video, but this is when it looked like that big, gigantic rain-wrapped tornado, because that's what was happening. All this precipitation was wrapping around the circulation, and it was starting to wrap up. So here's a video of the tornado, a second tornado that was near Fayetteville, Dunn, and Benson, and Wilson areas. Let me go back and see if I can show you that one more image. All right, let's see what else. Try to play this. Now there is some audio, but I'm not. There it is.
The location is Wilson County.
We'll crank this up, see if we can hear it.
795 north at mile marker 5.5. Again, Wilson
Sorry,
County, 795
What's that?
north at mile marker 5.5.
Yeah.
Large tornado on the ground, somebody north-northwest. Again, large tornado on the ground.
And you'll start to see it come out from behind the trees here.
What? 795 north at mile marker 5.5. Looking north-northeast. Large tornado on the ground, all the way to the ground.
Look at that thing. Oh, it's definitely spinning. Look.
Yeah. We're sitting right here.
That's a good move.
That would be inflow.
Stand on the roof of the vehicle. What is close?
The amazing thing
Did those
about
two
this-
guys make it, or?
The amazing thing is to look at this whole thing rotating, and then here's your tornado right there.
Wow.
There's somebody hiding under the overpass.
Oh yeah.
Always,
Yeah,
always.
Once these people stop.
Now, that is the worst place to be other than on your roof, right?
Yeah.
We also made traffic.
I just always wonder in these videos, like, these people driving at what the heck are they thinking?
They're not thinking.
I was just I guess I messed with
I noticed somebody's driving by me right now. Which I think people probably got wise and said, oh no, that's close.
Was this like a station truck, or was it a personal vehicle?
This is a personal vehicle.
Because the one thing you said, like, you know, WCNC News. Wait a minute.
Yeah, so you guys are like this.
Oh, this one's awesome.
This is
This guy's
same
such a
tornado.
Yeah, but you gotta hear the audio.
Oh yeah. I love this guy talking to his wife on the phone. It doesn't look like it's very strong, it's just lifting up trees.
The nearest train Probably down the road from your house, this corner. There's a roof on the house.
Is that his new hood blowing up?
That's debris. If you saw power flashes in the side.
Yeah.
That's the
So
commercial.
needless to say, that guy was an idiot.
Yeah, but he's got on YouTube,
Yeah, I
man.
think he was on every newscast in the country. There's a good view of it as well. And you can see all the debris moving around here. Pretty high up, so this is why the dual pole and even the next rad was picking up a lot of debris in this. That's Nate Johnson, actually, from RAS, famous at the radio. So there's a couple little videos, and then, I know you all saw this. Yeah. This is the time lapse of it approaching downtown Raleigh. And here's what I was talking about. This is mostly rain. The tornado is actually right over here. And it looks like the rain was wrapping all the way around.
Notice how no cars are going in the other direction.
Yeah. And whoever this camera guy is very brave.
What was it through the city, like EF0?
There was some EF1-2 damage, and if you look, but at this point, you actually see it's a multi-vortex tornado embedded in there. This should replay.
Right near where he's at, there's only someone on the tree dead.
Let me replay this again. We'll replay it one more time, because it's pretty, if you look carefully, you can see, this is all rain, but watch as the rain shield gets over the camera, and then look in the middle here.
Yeah.
If you look carefully.
Right there.
You saw, obviously there's the vortex right there.
I have to call you back.
And you actually see a couple, it looks like there's a couple vortices going around in there.
It's cool.
So,
This guy lived to tell about this, or did he
Yeah.
just find his camera later?
they were going to leave it out there. So this was, by the time it ended, these were all the warning polygon. I've never seen half the state covered. I mean, at one point, every county east of pretty much 95 was under a warning, and then your special marine warnings, obviously. But these were the first couple warnings. We had 2 confirmed tornadoes touch down right there, and then those cells took off, and then the one in Sanford, which you can see that track. Look at that. That thing started in Sanford, North Carolina, and was warned for all the way up to the lower Chesapeake. So pretty amazing when you start to think about how many warnings are. And this is a product that we have that we use on our radar too. These are the mesocyclone tracks. So you get a good view of your supercells, the way they tracked. None of these were cheapies. So this is the cell that started down here and tracked all the way up to the Chesapeake.
That's the one I was on the phone with my son at St. Mary's College, telling him people learning to run, don't walk
Yeah,
to the
a
basement.
lot of us were. So some of the factors that went in was the epic shear and low LCL. I'll talk about that. Simple photographs, very low LCLs, echotops, which is kind of a key thing that normally a lot of people don't look at. But in this case, there seemed to be a sweet point when these storms got to a certain height. They were able to tap into the deep layer shear and really crank up. And then gravity waves. This is very controversial because there was evidence of these there, but a lot of people don't buy into this theory. But I'll show you a couple things I'm talking about. So low LCLs, look at condensation level, makes much easier for tornado genesis. You know, so rear flank downdraft and storm inflow relationship comes under the mesocyclone a lot easier. And interesting study by the Warning Decision Training Center out at NWS. 64% correlation to significant tornadoes when you have a low LCL. They found that when the LCL, the medium LCL is 780 meters, you have a pretty good chance of a significant tornado. So what was it like for this one? Well, if you look at the buff kit that morning, this was the NAM. The LCL on here wasn't too low. It was pretty low, but only about 12,000 feet. But the good thing about this event is we had a special sounding. GSL launched a balloon at 16Z. And one of the, I don't know why that shear's showing up. That's a shear. But if you look at the LCL, I don't know if you guys can see that in the back. Remember that 780 number? We were at 262. So 64% correlation to a 780 meter LCL for significant tornadoes. And here we are, 262. The shear was important because you see that number, 611? And then look at your sickle. And what I mean by sickle, it looks like a sickle photograph, and you see that little kink there? This is something, if you ever want to chase, if you see this on the sounding, you're going to get some nasty long track tornadoes. So why are they important? Well, here's your sickle shape photograph. Where's that from? May 4th, 1999. Oklahoma City. Other thing is this kink. This is something I'm still researching, and a lot of the guys out of Oklahoma are looking at. These kinks above, right halfway through the sickle here, tend to have a higher, higher shear and have some correlation to the significant tornado. Now I talked about the shear, and this is the correlation with non-tornadic, weak tornado, and significant tornadoes. And you can see the ranges over here. This is storm relative helicity here, from 0 to 400. So when you're in this, 250 seems to be the sweet spot right here. But 250 to 400, boy, you're going to get significant tornadoes. This day, 611. 611 is off the charts. It wouldn't even show up on here. It's a very extreme event. So all of these things with that sounding right away, I think when that sounding went up is about the time the high risk of the PDS tornado watch came out. Almost identical. So this is a case where having that special sounding was very, very vital. Examples of the low LCO. We talked about this. You can see how low the cloud base is. There's a lot of visual clues to this that you could see that day as well. The echo tops. This were the echo tops over me when they were crossing over my house. They were between 30 and 40,000 K. Once they got over here, 50 to 60,000. And then they became mature mesocyclones because they were able, the storm was in a pretty high shear environment, but the storm was so shallow that it wasn't able to tap into the deep layer shear. By the time we got, and this was about 11 o'clock, we missed out getting hit by these by about 2 hours. Two more hours of heating and lift cranked up these updrafts, and they got up to that shear. Gravity waves. Talked about this being a little controversial. This is a great picture from Iowa. Dr. Tim Coleman down at University of Alabama, Huntsville, he's done some research on these about compressing the storm, making them spin faster, the old conservation of angular momentum. You know, the figure skater pulling their arms in, tether ball, the ball gets shorter, the ball spins around the pole faster. He also found that gravity waves have wind shearing, and they can tilt the shear and make them spin even faster. So gravity waves can make storms spin faster. Well, he runs this model called the GRITS model, and whoops, go back. And this is kind of an example of what that looks like. He's got a gravity wave based on model data coming in, and you can see how the storm inflow and height in meters, and then the vorticity increases. So that's kind of an example of what that looks like. And I did see some examples. Now this is the most controversial one. This was the first day of the outbreak. There looked like there was gravity waves in here, but these may be orographic in nature. This is the one I'm not 100% sure that's a gravity wave. Because the thing about gravity waves, they may be there, but if there's no cloud or any moisture to pick them up, you're not going to see them on a satellite image. You can see them on radar imagery if you know what you're looking for. The Clinton, Mississippi tornado, if you look carefully, it looks like there's some waves or some gravity waves there. And then the morning of our outbreak, I picked on the satellite image. If you look carefully, it looks like there were some gravity waves in there. And I do think there were gravity waves because this is a 3-day event. Remember that map of the 3 days? One of the things that gets gravity waves going are huge excursions into the stratosphere because you're rocking the atmosphere. So that's one of the things I think, 3-day event like this, you're probably going to get gravity waves because the updrafts are punching so high into the atmosphere that they're causing these gravity waves to be kicked off. And if any one of these interacts with a supercell, it could help form a stronger storm. So the death toll right now still stands at 25 in North Carolina. It's pretty amazing when this happened on a Saturday in densely populated areas, when the major cities hit. All right? 12 of the fatalities, though, came from Berkeley County. It's a large mobile home area, and most of the population is Hispanic in nature, and they didn't get the warnings in Spanish, they only got them in English, so they basically didn't get the warning. That was a huge factor in that area. The other thing, social media played a huge role in this. Because it was the weekend, most people don't watch TV on the weekend, all right? I work in TV, I know people don't watch TV on the weekend, all right? It's Saturday morning, Saturday afternoon, most people are at the hardware store, they're at the soccer game. How are they getting warnings? Social media played a huge role in this, and not just from that part of the state. I was tweeting, Facebooking, sending out information, the Weather Channel's sending out stuff, people up and down the East Coast, weather enthusiasts like us, are sending out information on social media that people are getting to people you don't even know. And that's the cool thing about social media. You may have a small group of friends that you think you're communicating with, but one of them has a friend in Eastern North Carolina. They're forwarding, sharing, or retweeting something you sent out to their friends in Eastern North Carolina. That person is, it's like playing telephone. That message starts getting sent out multiple ways. So social media played a huge role, and I think it actually helped in this instance warn people on a day when the TV and radio was not the prominent form of communication. People had their smartphones with them, they knew. So to have that many tornadoes occur on a Saturday in densely populated areas and only have 25 dead is, in my opinion, actually pretty good, considering 12 of them died because they got no warning, they lived in manufactured homes. Any questions so far? That's the end of that part, and I got the second part coming up. Yep.
Can you explain how the gravity waves actually help the